Good morning, students. Today we are going to see the topic physical clock synchronization. So physical clock in distributed computing, this is different from centralized system. Okay, centralized system, we have one server. Then based on the server, depending upon the server, the remaining systems will work. But in distributed system, the more number of systems are connected via network. So here the physical clock synchronization is important because the number of systems are connected via the network. Okay. So the clock is synchronized by using the network time protocol. Okay. The network time protocol is defined by the UTC time and the particular machine's time. Okay. This is the perfect time mentioned by DC by dt. This is equal to 1. This is the perfect time. This is slow clock. This is fast clock. So these two, slow and fast, should be synchronized by using the network time protocol. Then here in distributed system there is no common clock, but in centralized system we have common clock. Based on the clock the time will be measured, but in distributed system there is no common clock. Here functions is based on its own internal clock. Okay, since there is no common clock, the functions operations or process functions is happen based on its own internal clock. Okay, then the time measured based on the three components. The first one is time of the day at which the event is happened in a particular machine. Based on the machine, or in a particular machine, what is the time? Then next thing is the time interval. The time interval between the two machines, the events will be interchanged or process. The communication will happen like. Then third one is relative ordering of the events. So these three components are used to measure the time of the particular clock. Why we are studying network time protocol? Because in distributed system we don't have a common clock. So each system has its own internal clock. So more number of systems are connected via the communication network. So there should be a synchronization. So we are studying this network time protocol. This time is measured by using these three components. The next basic terminology in network time protocol is the common time, frequency, offset, skew and drift. The time is the time of the particular machine the process is running. This is mentioned by the Cp of t, which is equal to t. This is the perfect time. They are telling perfect time. The next one is frequency. The frequency is mentioned as Ca. Then offset is reported time and the real time. So difference between the reported time and the real time is called offset. Okay. Then next one is skew. The difference between the clock and the perfect clock. The machine at which the process is going on, the clock of the machine in which the process is going on, then perfect clock. Okay. The difference between the clock and the perfect clock is the skew, is measured as a skew. Then drift. Drift is the second derivative of the common clock. Sorry, not common clock. The clock time of the particular machine. Okay. This is the same server within a server. Same server. The process is communicating. Here, different server, the process are communicating. Then this is mentioned as server A. Process A is send the message to process B within one same server, single server. So T3, T2, then T4 time. This is mentioned by T4. This is mentioned by T2. The different server. Consider the server A. This is server B. Then the messages or the processor are communicating the events or messages by using this. We are calculating like this: Ti minus 3, I minus 2, then Ti. Consider this as a Ti. Server A sends the message to server B. In this particular time, the message is received Ti. assuming t is equal to t dash, offset is calculated by ti minus 2 minus ti minus